Object-Oriented Software Engineering, Unit 1, Lesson 7. In the previous classes, we have seen the system development life cycle, in which we have seen the system development as a process of change. And as the second part of the system development life cycle, we have seen system development and reuse. And as the third part, we have seen the reuse of other descriptions. Coming to the fourth part, the process expresses more than a method. A process must be able to express the underlying method. As we have seen in the earlier classes, it first started with architecture, and then a method was described, and then to industrialize the method, a process was created, and then the process had led to the data. So coming to the process, a process must be able to express the underlying method. So process description defines how different sub-processes should cooperate and to what extent they are carried out in parallel, and how the people who are engaged are to cooperate. So each sub-process is independent of the location of other sub-processes. The development therefore can be split up and carried at different locations. In other words, a process description is an enterprise model for the system development organization. A well-organized process provides version control as well. So it is possible to replace a sub-process with a new sub-process performing an equivalent task. This is one way of adapting the development process to a completely new kind of application. For example, it is customized for each specific database management system and the programming language. So coming to this figure, the process classes can be specialized. Now this is a UML specification, UML diagram, which shows the generalization and the specialization of each of these classes. So with respect to the programming language and the database that is being used, each of these languages or the databases are a kind of specialization of the object design. To describe the specialization consistently, the process classes are allowed to inherit other process classes. So this is clearly shown inside this UML inheritance diagram. Then coming to the computer-aided systems engineering. Apart from looking into the kind of architecture we use, the kind of method that we take, and the process that is used to industrialize things, and the tools that are required, we come to using the tools that are required for the systems engineering. We call these tools as computer-aided systems engineering tools, or in short, we call them as CASE tools. So to be fully efficient, the development work also needs computer-based tools, namely CASE tools, that is computer-aided software engineering. When large systems are developed, all documentation must be consistent. An object must be given the same name everywhere in the documentation. However, a tool that supports hypertext links are even better object-oriented. The tool that presents the reference, for example, as the object's name. Tools can be used to automate a large number of tasks, especially trivial ones of cumbersome volume. So coming to this diagram, in this diagram we are able to see that different persons need different views of the system, but all these views are composed from the same system information. So the same system information is viewed by a developer in one sense, by the sales person in another sense, and the service person in another sense. So when documenting a complex system, it is desirable to present the same information in several ways so that different people can gain a better understanding of the system that is modeled. Developers typically want to view association between objects as purely textual description in a document, arrows in diagrams, and compilations in cross-reference editors, or we call it as browsers. So a more sophisticated development may adapt a different category of developers where they can receive the information precisely. For example, a project leader is only interested in the overall descriptions, but the designer may need to see all the details. Finalized documentation may also be desirable sometimes. Therefore, a tool must support the process, that is, based on the process can be integrated into the tool. Example, supporting modeling decisions on handling change proposals. So computer-aided tools can lead to massive productivity improvements. Then coming to the sixth part of the system life cycle, it is about the small-scale projects. So, as in how we use the architecture, we build some method and we have a process behind that, and then we have required tools that support that, and in all these things we need some small scale projects to be developed. Coordination around the maintenance activity is necessary even for quite small projects. The development process naturally precedes the product development. Only when it is decided that the program products are to be developed, one can choose a reliable development process which suits the software products. So this is about the 6 steps that are involved inside the system life cycle.